Hello, it's Chameleon, and the reason why I'm recording this video is because something very interesting and special happened 2 days before. Um, Basically, I've read the comments on one of the puzzles of mine called Toe Tactics, uh, and I saw that person with a nickname apiyo left a good comment and pasted a link to the video itself. So, of course, I straight up watched the video, and it looks like their video channel called apiyo Puzzles is mostly about solving cryptic crosswords. But apiyo decided that he also wants to solve some variant Sudoku puzzles on the channels, and this was actually the first variant Sudoku puzzle on the channel that he solved, not counting one Sudoku cryptic puzzle crossword. I think it was by Marty Sears, if I remember correctly. So yeah, basically someone just decided to take my puzzle to introduce the viewers of their channel to the world of the variant Sudoku. So of course, it's very heartwarming. So I decided, why not to return the favor and do exactly the same and solve a couple of puzzles by apiyo. So I basically tried a puzzle called Fog of Wars by apiyo yesterday, and it's like spelled with PH, fog, so, of course alluding to the Fistum Fell ring. And it was quite a nice puzzle, so today I'm going to solve one or two puzzles on a camera and release that. And I will start from the puzzle called Red Color. It's rated. It's rated as 4 stars for difficulty. So it should be hard one, but not too much. So let's look at the rules. We have normal Sudoku rules. We have regular Kropki dots. Looks like you have only the black ones. So digits on the dots are in a ratio of 2 to 1. One of them is another doubled. We have standard thermo. Oh, but it's themed. It's themed like a snooker cue. A very interesting interpretation. I hope that that's the start of the thermo, because like the rules say it starts at dark brown. But which of them? Hopefully this one. I'm going to just assume that that's the start of the thermo, in case it's regular rules as it's mentioned here. Okay, even odd cells. The blue piece of chalk. Yeah, sure. Is an even digit. The cue ball in box 2 is an odd digit. And we have some special rules. Okay. Perimeter sum. The perimeter cells of the grid sum to 147, a snooker maximum. Well, I have to be honest, I know like zero about snooker, but I watched a few games. Okay, so these digits sum to this number. Okay. And we have red/color combos. Each of the boxes 2 to 7 must contain a horizontal domino containing 1n. 1n is the box number. For example, box 2 has 1-2 domino, box 3 has 1-3 domino, etc. The 1 always comes first, meaning to the left. So we could have something like that and like that. Yeah, makes total sense. I guess it's also about the snooker, like you have to do all balls in the order, if I remember something about the game. The one always comes first, and each such domino is fully contained within its box. Okay. It looks like it's... yeah, that's the end of the rules. And let's reset the timer and see what we can do. Well, the block crop dots obviously contain some special set of digits, and 5, 7, 9 cannot be on the crop dot. Also, yeah, like one of them is 3, 6, one of them is 1, 2, and one of them is 4, 8. So 8 and 4 always go together. So if these are not 4s, then these are not 8s. So 8 goes somewhere here. Yeah, and we need these boxes to have this interesting rule. Okay. Yeah, and these are also crop dots. Well, if this one is even, then it doesn't have much options. And this one I probably don't want to pencil mark yet. Oh! I see. So, yeah. The easiest thing that I could do about this rule is to realize that because one always comes first, the domino, so in none of these boxes, like 2 to 7, one can never go in the third column. So we like have ones in these places, in these boxes, so they align, and we have one here that goes together with the 2, and one here somewhere, I think. And I don't know if I want to pencil mark that. Yeah, I want to pencil mark that. So basically we have in this box we need 1, 2 domino. But 2 cannot go in this column because of this pair. So 2 goes here, 1 goes here. So in this box 1 goes here, and 5 goes here, pointing at this cell. So far it's quite an easy puzzle. Okay. 1, 4 here, 1, 7 here. Yeah, 4 goes here just by Sudoku. There's nothing to pencil mark even. I probably should look at this clue very soon. But let's... Oh, we have a thermometer here, so that's not a 1, that's for sure. Oh, so that's not a 5, because we must have a domino. Okay. Oh, maybe now I want to pencil mark this cell, because it's not a 1, and it's not a 5, and it's an odd digit, so now it makes some sense to do that. Let's see. Yeah, I know that 4 in one of these two cells, but I don't think that it worth pencil marking. Well, I can mark that 2 goes in one of these just by Sudoku, and not here by the thermo. Okie dokie. Yeah, let's look at this one. Oh, actually, maybe let's think about the perimeter. So we have these digits that sum to this number. Yeah, it looks very much restrictive. Okay. So if we remove these 2 rows, that's 147 minus 90, which is 57. Okay, so let's add and subtract these cells and say that we have 90 here as well. By the way, it was the same exact trick in the Fog of War puzzle. Okay, so I think that these 4 cells must sum to 180 minus this number, which is 33, I think. Oh, so that's just forced, right? So 4 digits that sum to 33. Like the absolute maximum is when we have 2 8 9 pairs that sum to 34. So basically we have 2 9s, 1 8 and 1 7. That's the point. But I can tell for sure that that's not a 1. 1 is here. Oh, which also means that... Oh, right. We have this funny clue here. So... Yeah, we need to place 1 7 somewhere in this box. So that's never a 7, that's for sure. So we have like 1 7, something like that. That's cool. None of these remaining things in the rows and columns contains a 9. Maybe it will turn useful at some point, but probably not right now. Okay, let's look at this one. The cages read as 2 two-digit numbers sum to 147. So this number plus this number equals 147. So I guess we have two cases here. There's the case when these two just sum to 7 and these two sum to 14. That would be kind of naive way to do that. And there's also a case when these two sum to 17, so it would be a 8-9 pair, which I see has some implication on this cell, but let's put it aside for now. Okay, so we have 8-9 pair, and the rest sums to 13 because we borrow one digit. So theoretically we could have 4, I guess. Oh, actually I see that we can't. Okay, so yeah, so first of all, that's just not a 9 because of these two 9s. That's for sure. Yeah, but my point is I'm looking at the case where it's 8-9 pair, so it would be like 8 here and 9 here. So none of these cells would be able to be a 9. So while we could have a 13 here, it couldn't be 4-9, so it's still like that, I think. Okay. If that's not a 3, something strange could happen, actually. Because, like, if we exclude 7 and 9 from here, we're left with 6-8 at most. Oh, wait a moment. There's no 5 here. Wait a moment. Okay, so I know that I have 13 or 14 here. And if it's 13, it cannot include a 9. But if it's 14, it cannot include the 9 also, because it doesn't have a 5 by the column. Well, that's definitely an interesting observation. So basically it always contains a 6, I know. And it's 13 or 14 with 7 or 8. Yeah, that's quite interesting. I don't know yet how it helps me, but it's interesting. Okay. So, in this box I need a 1-3 domino. So it could be like 1, 3. Okay. Oh. Yeah, that's quite tricky. Oh, also, this cell, that's the end of the 5 cells thermo. I shouldn't forget about that. So that's at least 5, but it's not a 5, and it's not a 6. So it's 7, 8, 9, and I think that we just have a 6, 7, 8, 9 quadruple here. Yeah, it totally looks like we do. So that's just a 3. That's a 4, 5 pair by the column. Oh, and now 1, 3 domino goes somewhere here. That means that this one cannot be 8, 9 anymore. So it sums to 7, and it has a 1 here, so that's just 1, 6. Actually, let's leave the 1 pencil mark just in case. Okay, no 6 here. These two sum to that. Yeah, I think that this clue is just done now. Yeah, looks like that. Okay, that's not an 8. We have 2 6s looking like that, so we have a 6 here. Oh, we also have 1 by Sudoku and 6 by the domino. Okay. Okay, so what now? 4 is a bit restricted here. I know that this one is not a 3 because it will go with the 6. So I guess I could just pencil mark it as 2, 4, 8, and it definitely has a 4. Let's see. Okay, so in this box we need a 1, 4 domino. I'm just trying to think if it could be 1, 4 here. Yeah, I don't see a problem with that. 1, 4 here is probably fine as well. Okay. So I think we... Oh, actually, let's return the 5 pencil mark, just to remind myself about the domino. Okay. So the perimeter kind of works. The cages definitely work. The dominoes are pencil marked. So it should be up to the regular Sudoku right now, more or less. Yeah, and these crop keys, of course. So let's see, what do we have by the regular Sudoku? Oh, for instance, these threes. Looking down, so 3 here, 3 here. What else? probably should just pencil mark this thermo, but let's not do that yet. Okay, 1, 5 in one of these. Oh, interesting. Let's see. So, yeah, having an 8 here will be extremely forcing, because it will put an 8 here as well, and now the 8 will be here. So it will be like 9, 9, and 7. Okay. Oh, actually, that's an interesting thought. So what I'm trying to think about is, like, we have basically 2 9s in the opposite corners, and we have 8 and 7 in opposite corners. So if this one is not a 7, then this one is not an 8. That's something. Okay. Yeah. 9 in this box is a little bit restricted. It's in 3 cells. But it doesn't exactly look helpful. Okay, let's just do the full pencil marking here. So 1, 2, 4, 6, 8. This one is not a 6 or 8. Oh, it's also not a 1, because 1 goes here. That was a little bit useful, I guess. So, or maybe not. So this one is almost anything, and this one as well. Well, not an 8, not a 6. So basically it's low. That's the consequence, I guess. Wow, but it still could be like 1, 4 here. Okay. I don't know, it looks to me like I'm missing something essential right now. Let's see. I don't think I could squeeze much from the special rules right now, and I almost used. Oh, this one is not a 1, because 1 is not here in this box. Okay. Interesting. If this is a 4, then this is a 4, and this would be just 1, 2, 1, like that. Oh my god, and it breaks. Is it really what I'm supposed to see? Oh, I guess there's an easier way to see it. Yeah. Oh! Wow, now when I think about it, it's really very cool. Wow! 4 cannot go here or here. And the point is, like, we know that this box has 1-4 domino somewhere. And we know that this box has 1-5 domino somewhere. Wow, that's very clever. Nice setting. So basically, we have these cells that are marked with 4-5. So let's see what happens if we put a 4 in the same row. If we put a 4 in one of these cells, let's say here, it forces this cell to be a 5, and we know that this box needs a 1-5 domino, and this box needs a 1-4 domino, and the ones will clash with each other. That's really cool. That, like, this small pair, I didn't realize the whole importance of it. Okay, so we have 4 here, 1 here. That's not a 1-6. That's just a 1-4. Okay, so let's see. This cell is at least 4. So this cell is at least 6, because 5 is gone. At least 7. Oh, so that's just a 9. Nice. Okay. So I guess it's just 6, 7, 7, 8. 4, 5, 6. Yeah, looks like that. Good. What else I can do with that? Oh, right, that's not a 2. Oh, this one cannot be a 4. Because of kind of the same reason. Yeah, basically none of these cells. What am I talking about? I just have a 4-5 pair. It's much simpler than that. Yeah, sure. Okay. Now. Well, I probably could pencil mark 9 in this box. And one of the 7-8s will go here as well. Actually, this digit will go into one of these cells and then here. But that's probably not the thing to think about right now. So let's see what's a useful thing. I still didn't resolve the 1-7s. And I don't know where the 7 and 8 go. Oh, I see something. Yes. So I think that the easiest thing to explain, the easiest way to explain this is to ask, where do 3 and 6 go in this column. So in this box we already have 3 and 6, so just by the digits it has 3 possible places. So if it's not a 3-6 domino, then 3 and 6 must both go to this cell. Okay, so this one is 3-6, and this one is 4-8, like that. Oh, so we have a 4 here as well. Okay. And an 8 here, which is not a surprise. Oh, but this one. Yeah. So we do need 3 and 6 here, and we already have a 2 here. So I think that's just a 2-3 pair, and that's just a 6. Good. So we probably have like 1-7-8, and I could remove these pencil marks. Well, not these. Okay, we have a 2-3 pair here. That doesn't really restrict what happens here, I think. Oh, okay. I think now I have the complicated thing again. So if this one is 8, then this one is 4, this one is 5, and we have no 1-5 domino. So that's actually 1-5. Nice. Okay, so 1-6 goes here. Do I know? Yeah. 3 is never here. So 3 is just here. Cool. Okay, so these dominoes already work, which is awesome. We also have 6s here. Let's see. Okay, so what's left here? We have 1, 2, 3, 4. Okay, so basically we need all many odd digits here, and 7 is definitely here. Good. Now this 4 is pointing to the right. So 2 places for the 4 here. Maybe I have something else pointing this way. Oh, I have a 5 here. So I think that 5 in the column goes just here. That's awesome. So what's left? Oh, 2 now is restricted in the column. So that's a 2. I actually didn't expect that to happen this way. Because 8 would be much more restrictive. So we have a 7-8 missing here. And looks like that's just a 2-4 remaining here. And 5-9 here. Oh, so that's not another one, because we still need a 1-2 pair somewhere. want to domino, I mean. I know that this quadruple contains both 3 and 5. Maybe it will be interesting at some point. Okay, I think this one is just 7, 5, 9. Let's see. 4 just by Sudoku. 8. A little bit restricted. Looks like 2 is still missing for this row, but I don't really know where it goes. I could pencil mark a 6, I guess. Let's check the rules again. Even odd cells, done. Thermo, basically done. Oh, crop key. I just missed the crop key. That's wasn't my best decision to make. So 3, 2, 3. And now maybe something will happen. Hopefully. 7, 5, 9. Well, maybe I should start coloring. I don't know, because these two are the same. Maybe it will turn useful at some point. I honestly don't know. Oh, actually, yeah, we already have 2 high digits here. So, if that's not a 5, then 7, 9, and 8 here. Oh, well, that's never a 9, that's for sure. So, 9 in one of these 2 cells. Okay. Okay, but now the crop keys are done. So all regular rules are okay. Perimeter sum is very close to be finished. Cages are done. And these are pencil marked. Okay, so I need to do some Sudoku again, I guess. Oh, that's so simple. That's just not a 9 because of these 2. Yeah, it was much easier. Okay, so I don't need the colors. And I don't need the pencil marks. Cool. Well, I have a 4 here as well. So what I'm missing here is basically 4, 8, 7, 9. So, for instance, 9. Oh, okay. That's actually interesting. So, like in this row, 9 is here or here. But in this row, 9 is also in the same columns. So we have a 9 here. Let's mark it like that. It's pointing down. So now the remaining cells for the 9s are these, I think. Oh, but here yeah. Well, why did I say that that's not a 4? Oh, yeah, by the domino. Cool. Yeah, so that's a generic 4-9 pair here. A true one. No. So, what's actually left for this cell? It's 6, 7, or 8, I think. Because it's definitely not a 9. Okay. And it should be something similar here, I think. So, yeah, let's see. Oh, I think it's just 7, 8, 9. Or actually, just 7, 8. Let's check it again. It's not 1, 2, 3, 4, 5, 6, 9. Okay, that's just 7 or 8. Meaning that we have a 7, 8, 9 triple here. Oh, well, that's so funny. There are two ways of proving that this cell is 6. There's of course an easy way by this triple, but there's also a tricky way, because we know that the corner cells contain 9 twice, and one of they contain 7 once, and they contain 8 once. So this cell is what's missing here. Like if this one is 8, 9, then it's 7. If this one is 7, 9, then it's 8. So it's one missing digit. And this one is what's missing here. So this 7, 8 and this 7, 8 are different digits. and they both see this cell. So it's just a 6. But yeah, we of course could use the easy way. Okay, so basically that's 7, 8, 9. Yeah. I actually have a feeling that this 7, 8 will be handy at some point. Yeah, but there's something much more simple actually. Where does the 7 go in this row? It's just one of these places. So that's not a 7. So that's just 8, 9. So that's 7. So this one is 7, 9. And that's 8. And that's 4. Oops. 4, 8. 4, 9. 7, 9. This one unwinds as well. and everything here basically done. Oh, let's not forget about the domino. Okay, let's finish the nines. Let's check. Yeah, all nines. Let's remove the colors. Yeah, and I think that we must have 7 base Sudoku here. So that's the domino. Oh, so that's the domino. Very nice. Looks like a 4 base Sudoku. Looks like this one is done. Wow, it resolved surprisingly fast. Oh, point and octuple here. So that's 7, 5, 7. Here we must have a 3, 2 and something, 2 and 5. Yeah, basically the rest is just basic Sudoku, so let's do it the fast way. Okay, so let's remember it again. So we had this perimeter rule that forced large digits into the corner. We had this interesting sum rule of 2 numbers that forced large digits here, and there was like this intersection of these 2 clues telling that there's no 9 here. So if this one is 8, 9, then this one cannot contain a 9. So that's basically excluded 4 from here. And the 5 from here excluded the 5, and it played very nicely here. And then by the thermo we had a large digit here, and this quadruple, making this a 3, looking into this box. Yeah, it was well, it was a hard puzzle, but it still was like a very satisfying flow. So I guess let's do the really hard one. It's marked as 5 stars on Logic Masters, and it's Fog of War, so of course I'm going to do that. It's called Downtown Fog. Oh, and 11 by 11 perimeter. That's interesting. Again, we have a perimeter rule. Nice. Okay, so normal Sudoku rules apply. Thermometer visits cell inside the 9 by 9 grid, and in the 11 by 11 perimeter. They do not intersect but may branch. Oh, they may branch? Okay. Well, I guess it branches here. Every thermometer must include at least one cell in the perimeter. Okay. This applies to all branches individually. However, the cell that 2 branches diverge from can fulfill this requirement for both branches. Wait, what? Every thermometer must include one cell in the perimeter. This applies to all branches individually. However, the cell that 2 branches diverge from can fulfill this requirement for both branches. Oh, so I understand. So let's we have a thermo here. It does something like that, and then branches somewhere here. I didn't really draw this properly. Let's do it again, and probably draw so smaller one. So let's say we have this one. Yeah, well, it makes total sense. Like we have like kind of two branching thermos here, but both of the branches contain this cell that is outside the normal Sudoku grid. So it makes perfect sense. Let's see what else we have here. A digit in a perimeter cell acts as a skyscraper clue, indicating the count of digits visible along its row column. It is visible if it's larger than all the digits before it. So standard skyscraper clues looks like. And of course the digit is partially covered in fog. Placing correct digit will clear the fog from surrounding cells in the grid and the perimeter. And the perimeter, yeah, of course. Well, actually, like fog of war puzzles, especially the ones when you need to deduce where some clue goes. I don't really like the fog of war puzzles that use the fog just to reveal the clues like one by one. I really want to see something that makes me guess how this clue goes into the fog. How does it continue? Where it goes next? Maybe it's one big line, or maybe it's two separate lines, like things like that. That's kind of the reason why I love fog of war puzzles. And I also like a lot the puzzles with outside cells that act with outside clues that act as Sudoku cells with some interaction with the grid. So yeah, that's to my favorite constraints. So of course I must give it a go, right? So I guess let's restart the timer and see what happens here. So yeah, well, this one definitely starts here and goes here and here. Yeah, I didn't really think about too much about the skyscrapers yet. So basically it means that one of these skyscrapers is at least 5, I guess? Yeah, if they are both less than 5, that this thermal breaks, obviously. Yeah, so one of them is at least a 5. But we don't really know like how it continues. Oh. Well, I actually don't even know that it must continue at all. It might just end here. Oh no! Wait a moment. So, let's check out that again. Yeah, thermometers do not intersect, but may branch. Which means this thermo, where does it start? Oh, wait a moment. Wait a moment. Let's see. Okay. I don't think that there is a rule that tells that the thermal bulb must be inside the grid. I think it should be possible that like the thermo starts here, let's say, and does that. In this case, these two still could be two separate thermos. Actually, let's think. Could it be just one? So, like one of the branches will just go like that. That's the point. Maybe I should use the line tool. So we definitely have that and that. So yeah, and that of course, and I will return to this one as well because it also looks quite interesting in terms that like it must visit an outside cell somewhere. Okay. So basically, what I'm trying to think about is like which color to use. Let's use green. Like if one of the branches connects, then we have like at least 1, 2, 3, 4, 5, 6, 7. Oh, so we. Oh, I wanted to say that we have a 9 in one of these, but we obviously could have some repeated digits in the thermos. But yeah, the point is, if this one is at least 7, then by the skyscraper, this one I think is at most 3. And it obviously cannot be a 1. Like, I mean, just by the thermos. So it would be like 7, 8 here, and 2, 3 here, I guess. Yeah, but my problem with that is I think it just works. So maybe it's the case. Another thing to think about is, oh no, I wanted to tell like where does this goes by Sudoku, but that's just total nonsense. Yeah, and I'm basically like inspecting this case, but of course, if the thermo goes like that, it's just exactly the same. It's totally symmetrical at the current point, so it should be enough to inspect only one of them. Yeah, so still, like, it would be extremely restricted. Oh, wait a moment. Maybe let's stop thinking about this one and do something extremely easy. 9 in the box goes in one of these. Okay, so maybe I have some troubles if 9 is somewhere here. So basically 9 here will make it a 2. That's very easy to see. Oh, that's so strange. I don't think it works. And but I don't want to actually put digit into the. Well, I know that it's wrong, so I guess it's okay to put it. So let's still do it this way. So if this is a 9, then this is a 2 just by the skyscraper. Then it's not a part of this thermo. Oh, no, wait a moment. This could be a bulb. This could be a start. So it will just go like that. I was going to say that it cannot be a 2 because it will need a 1 here and 1 is broken as a scraper clue. But it doesn't have to continue, it could be just the start. So maybe it's still fine. Okay. But this one actually looks very much broken to me. Because if this is a 9, then both of these clues will be 2 or 3. And now the thermo is definitely broken. So that's not a 9. Yeah, so if one of these is a 9, then one of these is a 2. And that's a separate thermo. I actually have a feeling that this would be a 9 just because of how symmetric the grid is at the moment. Just some random setter logic. Okay. Okay. So let's think about this. So it looks like a tiny restriction, but I think it could be actually quite helpful. So basically, because these cells are not 1s and not 9s, it means that these cells also cannot be a 1 or a 9. Because like 1 as skyscraper needs a 9 here, and 9 as a skyscraper needs a 1 here. Okay, so definitely not a 1 or a 9. Let's mark that. The pencil marks look ridiculous, but I have a feeling that it could be useful. What about this one? So in order to have some outside cell, it needs to go at least like that. So 1, 2, 3, 4, 5, 6. This one is at least 6. Oh, I should have started from that, right? So it means that this one could be at most like 1, 2, 6, 7, 8, 9. Yeah, at most 6. Which is quite huge. First of all, it means that these are just from 3, 4, 5, because these are between these two cells. But more important, that's both less than 7. So now it's not possible, I think, that that it's the same thermo, because that would be at least 7. It definitely cannot be. Oh, actually, none of these could be a 4, I think. Because it will break the other end. Yeah, like basically they need to be at least 3 apart. So one of them is 2, 3, one of them is 5, 6. Which probably breaks the 8 here, right? So 8 would mean so 5 is 1, let's say, I don't know, 2, 3, and then 3 more numbers. So I think that 7 is still okay, but 8 breaks. 8 will make one of the clues. At most 4. Okay. That's very interesting so far. So how do I mark that? I guess I could do it like that. Let's use the red one. Okay, these two don't connect. Okay, so we have at most 7 here. So after visiting an outside cell, it could do one more. So I guess basically there's 1 degree of freedom here, so that's 5 or 6. But I don't know where it goes then. Well, I guess it never leaves this area, like it cannot leave this boundary. Okay. Well, I'm just 1 step from having some digits, I think. Also, I still need to place 8 somewhere in the puzzle. Okay. This one, of course, cannot be 8. But this one could. Yeah. If one of these cells is 8, then one of these clues is a 2. And if one of these is 8, then the low clue will obviously be 3. That's interesting. So basically, if I say that the high digit here, yeah, basically like the high digit here and this one are all linked together. So if that's, wait a moment, it's hard to think about. So yeah, so if that's a 7, then the high one here is 5. And we have 3, 4 here, and thermometer here, kind of. And by the thermometer, I of course mean just something that goes down from 7. Yeah, also, if one of these is a 6 on the other side, then this must be a 6 as well. So I guess it means that, like, in the direction from this cell to the large digit in one of these, we have at least one cell that is smaller than this one. Okay. And of course, these two could be just the start and the end. I don't think that there's a rule that tells that some thermometer that we don't see must continue, because they already have an outside cell. Okay. Oh, interesting. Yeah. 5, 4, 3, 2, 1. Yeah, the interesting thing about this one is if it's a 6, then it goes like 6, 5, 4, 3, 2, 1 in some direction. Let's actually mark it like that. So having a 6 here will place a 1 in like one of these cells. So one of these, basically we have like 1 or 2 as a skyscraper in one of these cells. I guess I could mark it. Actually, if it's a 7, it could reach here as a 1. But it's still the point. Like if basically if this thermo ends with a 1 outside the grid, then the skyscraper will put 9 in one of these cells. Then that all will rule out this one. So maybe I should think about this intersection. Like, basically I could say that if this is a 9, then this one must be a 7, because 6 will put a 1 in one of these. That's definitely interesting. So maybe this one actually breaks. Yeah, but the problem is, like, I basically need one of to know the digit in one of these cells to get started the fog of war puzzle, because right now the grid is symmetric, so I just, there's no chance that I know one of these digits. I must know something here. So it's probably going to be this one, because I probably should be able to disprove a 9 here. That will put a 2 in one of these and maybe do something. So let's see. Nine. We'll make it a 7. So what's the implication for these? Okay, so if there's no 9 here, oh, I guess, oh, wait, so, yeah, so 7, okay, I just noticed something else. I think that now these clues cannot be a 9, because 9 as a skyscrapers means that we just go like 1, 2, 3, 4, 5, 6, blah 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 blah. But that's not a 4. So these are not a 9. There are at most 8. So these are not an 8. And there are, well, am I right? Maybe I'm wrong. Yeah, I'm just like thinking about the ways to make a 2 clue. But I could say that 8 in the box goes into the same 3 places now, because now these 2 cannot be an 8. So let's continue thinking about. Oh, that's actually quite useful. So let's see. So we have 9 here. One of these would be an 8 without having a 9 here. So one of the clues would be 3. Because of having 8 in this cell. So the other clue will be 6. And it will break because this is a 7. Wow, that was quite complicated. that was very hard, but that's a nice deduction. Okay, so basically the 9 is in one of these. Oh, so actually this is going to be the digit, right? So first of all, 9 in one of these means 2 in one of these. But this means that the second digit is a 5 or 6. So basically the point is we cannot have a 3 as a skyscraper here anymore. So we cannot have an 8 in one of these. So the 8 is here. Ta-da! Cool. Oh, so we do know that these are the start and the end. Very nice. Very cool. Okay. This one looks like a 2 to me. And this one is bigger, but I don't know. Is it really much restrictive? What if this one is 9? Okay, if this one is 9, then this one would be a 3. And this one will rise. Which is quite problematic. Okay, so first of all, we know that the ends are at most 8. So the start is at most, I think it's at most 5. And the reason for saying that is if it's, yeah, it could go like 5, 6, 7, and 8 twice. I don't think right now that having an 8 twice is an issue. Maybe I should think more about it, because I kind of want to exclude the 5 from here. But yeah. So let's think about the 9 here first. If the 9 is here, it means that this one is a 2. And so it rises this way. So this one will be 3 or 4. This one will be 4 or 5. So yeah, the only way for this to be 9 is if it's 5, 4, 3, I think. So maybe I should think better about this one being a 5. Oh, wait a moment, I already have a 6, 7 here. So these cannot be a 6, 7 pair. Yeah, that's quite easy. What's not easy is to have pencil mark together with that. So maybe let's remove that for now. I don't know. Maybe let's have it only when it goes outside. I don't know. Okay, so let's repeat the deduction again. If this is 9, this is a 2. This one rises this way. 3, 4, 4, 5, bigger than this cell. This is a 2. Yeah, I believe it works. So now this is the 2. This one could be removed. This one, well, I don't know. Yeah, but this one is for, okay, so it rises this way now. Oops. Okay, so these, I think, need to be quite small now. So basically, Having a 5 or 6 here means that I need to have one or two numbers here that are smaller than this one. And I definitely cannot have a 7 here, that's for sure. Actually, let's mark the clues so that just work as green. Okay. Okay, so at least one small digit here. Oh, wait. Are they just automatically smaller than this one? Oh, wait, it's not about being smaller than this one. It's like, it's about the order of these two, basically. Okay. So let's think about it. If they increase, if they all increase, then six. Oh, I guess even 4 or 5 is okay here. Okay, but yeah, 6 definitely doesn't work here. That's for sure, because it just will make it it will just will make it a 4. So that's like at most 5. So this one cannot be a 4, I guess. Oh, it cannot be a 3 as well, because like we will again have too many digits here. Okay, so this one is quite small. I guess that this one just works automatically. Having an 8 here probably is okay. I guess if that's... Oh, wait a moment. What about this one? Yeah, like my point is, if we have already a 9 in the second row and an 8 in the first row, how could one be a 2? Oh, it could be like some big digit, like 7, 1, 9, I guess. Yeah, okay, so yeah, there are many ways of making a 2 clue, I guess. Okay, so never mind. And 1 is, of course, possible from both sides. Well, 1 is one of these, that's for sure. 5 here will force a 6 here. And 6 here basically means that this one is a 6 as well, and it goes as thermo. So but it would still work. And 7 means that this is a 5, 4, 3. And this is still a thermo. So the only way for this to go down to this direction is if this is a 5 and this is a 6. Okay, so this one will be a 7. Yeah. So this would be a 5. So what I'm supposed to do now? That's the big question. Oh, if I look very closely, I know that it goes here by this small corner here. I honestly don't know if I'm supposed to use that. That's sneaky. I'm kinda also not sure if it does something. Well, it tells that it goes this way. That's for sure. Yeah, let's use that. So that would be 4 or 5. Let's remove these. And something here is 1 or 2. Okay, so now 4, 3, 2, 1, 9. Like I will kind of, if this is 6, I will know how exactly it goes. It will be like 6, 5, 4, 3, 2, 1, and 9 in some row. So maybe the 4 will break something? I don't know. It doesn't look like that. So if this one is 4, for instance, then that's 5. This must be a 7. This must be a 6. Oh, but 6 doesn't work with the 7. Okay, so somehow 4 here breaks. And here as well, right? Yeah, basically 4 in this row means 5, 6, 7, but it also means that this one is a 5 and this one is a 6. Yeah, 4 is not here as well, so 4 is one of these. Okay. Oh. 5 here breaks? No. I don't think it does. So basically 5 in one of these will mean that it's a 4. Okay. Oh, what about if that's a 2? So if that's a 2, then it will go like, it could go yeah, like basically if this is a 2, then it will go like 3, 4, 5, 6, 7. But also 3 will be excluded from here, 4 will be excluded from here, so that will be 6 with a 7. Oh, I can see it in other way. So 7 here means that's a 5, 4, 3. Yeah, so if 4 and 3 in this row is gone, then yeah, basically I know that it ends with the 1. And probably still needs a 2 in one of these. Let's see if we have a 3 here as the thermal cell. So 3 will make it 4, 5, 6, and this one be a 7. So yeah, we have some 2 action here. 3 or 4. Actually, 4 is not here. And 4 or 5 here, which is kind of this one. Okay, so no 2 here. So 2 is one of these. Okay. I also do know that 9 goes together with the 1. So like the 2 goes to 1 diagonally. That's what I basically know. Not sure if it helps me a lot. Well, I do know that that's not a 2. So if it's 8, then this one is a 1. Oh, wait. I still have the same thing here, right? If I have 4 as a thermal cell here, then this will be 5, 5, 6, 6, 7. Still breaks. Okay, so yeah, the one in this row is just a 3 again. So now I know even more about this clue. I know that if it's 8, it starts with 1, 2. And then it goes like 3, 4, and 5 here. So 5. Oh, is it the point? Yeah, I don't think that 8 works here. Because it has only 1 degree of freedom, and 2 is excluded from here, so this would be 1. 3 is excluded from here, so it would be a 2. 6 will be too big, so that will be 5, 4, 3 will go in this box, and this is nothing. Well, that was extra hard, but that's not an 8, so that's not a 7, so the 7 in the box goes here. Okay. Now this one is just a 5. Oh, I probably could remove these marks. Oh, this one continues. That's interesting. Okay, so 5. So this one grows. So no, this one cannot be 1 or 2. So that's 1, 2, like that. Now this one could be anything. Well, this one is still not fulfilled. I still need to ensure that the 8 goes first, basically. Okay. Oh, but oh, that's a funny clue. Okay, so I think that this one is extremely restricted. Like I think that these two cells must have some like maximum sum or something. Because if the skyscraper is high, then the digit here is low. If the digit here is high, then the skyscraper is low. So I guess they must sum to at most 10. So let's check. If this is a 5, this would be at least 6, and the skyscraper is broken. Yeah, that's exactly like that. Okay, this pencil mark check is not a true one. This one is a total lie. Well, actually, I just proved that it's not a 5, so it's okay. Okay. So from 4 to 7. Oh, actually 5 just makes these cells like that. So what's left is 5 and 6. Okay. Oh, and this one is a new one. That's interesting. Oh, also this one is quite huge right now. So that's 6 or 7. So these cells must be quite restricted. So yeah, like again, this one is at most 4. And I'm even not sure that it could be a 4. Because if it's a 4, then this is a 5, this is a 6, so we cannot put 5 in between of 4 and 6. That's the point. So it will go 4 something, 6, 7, 8, 9, and that would be only 5. So that's not a 4, but it's not a 3 and it's not a 2. So that's just a 1. And now I know that the thermo doesn't go here. And actually, here I see that it doesn't take this corner. So the thermo goes like that, which means this. I don't know if I was supposed to use this deduction or not, but that's what we have. So 2, 1, 9. Awesome. 3 by Sudoku suddenly. Maybe something else by Sudoku. So what do we have here? 2 and 8 go here, and the rest is 6 and 7. Okay. Well, I don't think that 7 or 8 could be here. So yeah, of course they can. So that's just a 2. 6, 7, 8. Okay. I must know these digits by Sudoku. So that's 1, 8, 9. I usually don't do ridiculous pencil marks, but I think that here it could be quite useful. Okay, so here we have 6, 7, and 5. Okay. Oh. Yeah, like the same deduction of maximum sum of 10. I don't think that this thermometer could rise, because if it rises this way, it's at least 5, 6, 7, and yeah, the thermo is definitely broken, so it goes this way. I don't quite know how to mark that. I guess I could assume for now that that's a bulb, because it doesn't have to continue. Okay, so this one is at most 4, of course. And yeah, not a 1 by many reasons. Actually, this one is also not a 1. So that's at least a 2, 2 or 3 here, 3 or 4 here. Six here will make this one 7 and this one 5. Oh, what about this clue? It's still not fulfilled, so I do know that the 8 goes first, the 9 goes second, so if I remove the 9 here and an 8 here, it should just work. This one is interesting, so 1, 2, 3, 4, 6, 7, 8. Wait, what? So I already have 4 of them, so I need 2 or 3 more. Yeah, makes sense. I also know that this one needs to take some oh, wait, no, it already takes an outside cell. Okay. And these two also need some outside cells, but these two could actually be kind of like the same one. But yeah, but this one is still at least 5. So that's exactly wait, what? Why? Like 1, 1, 2, 3, 4, 5. Oh, yeah. Why did I tell that it's exactly 5? I honestly don't know. It could be 7 as well. So oh, but this one looks just like an 8. And now this skyscraper is quite restricted, so let's see. Oh, well, yeah, it's 3 or 4. Thank you. If it's 7, then it's 3. Yeah, basically depending on order of these. By the way, it's not a 6. Okay. So here it's lower, but not more than not less than a 4, sorry. And this one I like it doesn't actually matter if it branches or not, I guess. It's still at least a 6, like no matter which direction it goes, so it's actually at least a 7. Okay, this one is done, by the way. This one probably is okay. It would be quite hard to break it. Okay, this one again is at least a 5, so 5, 7, 8, which just proves that 9 goes here and here. Oh, actually 4 goes here and here as well. That's maybe more useful. 6, 5, 4, 3. So the skyscraper could be even a 3 somewhere, and it could go like into any direction. Okay, that looks okay. So what about 9 being here? Yeah, easy. Okay, so this one doesn't look restricted. This one doesn't look restricted. This one also looks okay. So maybe I should think about these two. So 2 or 3. This one is not an 8. So maybe I think about how I make a 2 here. If this one is a 9, then it's extremely forced. Because first of all, that's forced to be a 3. That's forced to be a 2. That's a 1. So what exactly happens here? Oh, that's actually quite funny. Okay. So if that's a 9, then that's a 3. And this cell is smaller than this cell. But it's also smaller than this cell by the thermometer. So that would be just a 4. So this would be 6 or 7. This would be 1. Oh, so that would be a 7, 6, 1, and let's say a 9 here. So it looks like it works. Okay, so what about the other case? If 9 is here. Then depending on the order of these. Yeah. Okay, so basically, if this cell is smaller than this cell, then that's a 3, that's a 4, 6, 7. Just proving again that this one is smaller. 4, 6, 7, 5. Oh, wait a moment. So if this one is smaller, then this one is bigger. Because it will go like 6, 5. And this will be a 4. So 8 will not be possible here. Wow, that's crazy. I didn't see it. Let's look at this again. It already has a 4. So it has 2 more. So it, like if it's a 7, then it will go like just 7, 8, 9 in some, and something in between. Okay. Okay, if that's... Oh! Okay. Yeah, right. This one cannot be a 4. That's the deduction because of the 3 here and the 2 here. And it cannot reach this side, so that's just a 6. That's a 7. No 7 here. No 7 here. Okay, so maybe now something will happen. Also, 6 by Sudoku. So now this one goes here. And this one is not a 4. Oh. Yeah, because of the 4 by Sudoku here. This one is not a 4, but it cannot be less. So that's an 8, 9. 8 goes here as well. 9 is somewhere here. Actually, what about this one? Yeah, I don't think this one could be a 9, right? 9 will make that a 2. Yeah, sure. So that's a 9 here. That's some progress. Okay, so we have just 4, 5, 9 here. Oh, so we know this clue. Well, I don't think that it helps at this stage, but we don't know. So 1, 2, 3, 4, 5, 6, 7. It's 7. This one. It's like 1, 2, 3, 4, but it's not a 4 and not a 5. So it's 6 or 7. Given a pair here, 8 is here, 8 is somewhere here. But this one could be at least 3, I think. Okay. Okay, so what about this one? This one is at least a 4, so 4 or 5. Oh, that's interesting. Like, here there are many low digits. So this one, this thermo, first of all, it goes here. And, oh, well, isn't it just a 4 now? Because it cannot be a 3? Yeah, I think so. So 4, 5. 4 is here, so that's not a 4. That's okay. So 5 here by Sudoku. And now this one continues like that and like that. Oh, so I guess the... Oh, by the way, it's not a 5. But I think it cannot be a 9 also, because it will go 9, 5, 4, make it a 3. So that's not a 9, that's a 4. And this one could be both. Okay, but now I know how. First of all, I know the 4 here. That's for sure. Also 8 here just by Sudoku, I think. What's left here? 6, 7, 9. That's cool. 9. So, well, so 1 goes just here. This one looks like a 2. But don't we just have this one? Okay. This one was strange. It just worked without any effort. Okay, so 2 and... Oh, it could be resolved. Okay, so it goes this way. So 1, 2, 3, and 9 somewhere here. That's a 4. I don't know why we needed this thermo, but it's totally fine. Okay, no 5 here. Okay, 6 here, already marked. 7 here. Okay, it should be all for now. Okay, this one just works. I already know that. This one works. This one, it's all okay. Okay, so at least 2 here. at least 3 here, but it still could be a 6 here, I think, and a 3 here, so a 2-3 pair. Hopefully doing something. Oh, I think I should know that it goes here, right? Oh, well, no. It could just branch. Okay, so I cannot tell anything about this one. But I don't like, yeah, the point is one of them is a 2. So one of these cells is a 1, but only this one could be. So that's a 9, that's a 5. Perfect. Let's go. Okay, so these obviously just work now. Oh, this one is maybe a naked single of some kind. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have a 6, 7 pair here and here. Oh, I already had a 6, 7 pair here for a while. Okay, so it was just much easier than that. Well, yeah. And the last digit is 1, which is not here. Okay, so here we go. Oh, thermo. And this one is a 3, obviously. Well, congratulations, that's not a 1. Oh, by the way. Boom, boom. Yes, so 1 goes somewhere here. That's all I know for now, I think. Oh, I know that 9 is somewhere here. Oh, so that's interesting here. Because, like, it could be a 9 here, or it could be 1, 9, like that, but the 1 wouldn't matter for the skyscraper. So basically, how it grows or vice versa here defines the skyscraper clue. That's an interesting observation. So actually, I think that I had something like that in the case when it's 9. So let's think again. 9 will make it 3 and 2. So this grows, but this one doesn't. Wait a minute, so that's a 2. Yes, so this one must be bigger, so it will be like 4 something 6, 7. So no 7 here, basically. It would mean I guess it's still okay. But the same here, like if it's a 1, this is a 9. Okay, so so it basically means that that's never a 4, I think. Because 4 will mean that it must go. No, it's still good if it's a 1. Yeah. So the 4 here will mean that that's a 8 and 9, and a 9 here. And the 4 here again. 7, 6, something like that. Okay, but it's getting into the strange territory. Let's do the easy stuff, I guess. For instance, 1 is here, 4 is here, and what's left is 2, 3, 5. 5 is here. That's a 2-3 pair. So here the last digit is 1. And I must know some more information about these. So what's left? 2 and 3, obviously. 4, 5. Is it a naked single 4? 1, 2, 3, 5, 6, 7, 8, 9. Yes, it is. Okay, so now this one looks just like a 1-4 pair, so I must know this digit. It's a 5. So now this one is probably the naked single 7 again. That's so strange. By the way, I didn't think about this one enough, but let's take this one first. So 1, 2, 3, 4, 5, 6, 8, 9, 7. Okay, now 5 is here by the thermo because the other one is 2, 3. Now this one is a 5. So one of these is bigger than well, it's much easier. Yeah. Okay, so first of all, I have a 1 here and a 4. So that's not a 1 and that's not a 1. And also I must know this one, right? So I have 1, 2. That's a 2, I think. Well, I don't exactly know how it helps me. So 1, 2, 3, or 4. Nah. Okay. This one looks just like a 6 by Sudoku. Oh, so it should help a lot. 6, 7, 6, 7. Yeah, this one actually helps. So that's an 8, 9, 1, 8, 1, 6, 9, and one more, 2 or 3. That's not a 1 because of this 9, so that's a 2, 3, 2, 3, 2. Let's not forget about this one, which is a 3. This one works, this one works. I guess I can do this one just by Sudoku, right? So I need 2, a 3, 8, 7. Oh. Did I do something wrong? Maybe it just... Oh, puzzle is not yet finished. Yeah, sure. Should I just enter all... Oh, this one, yeah. By the way, this one works. That's cool. Okay, 1, 2, 3, 4. Ta-da! Wow, that was a very intriguing puzzle. It was a journey. By the way, let's unhighlight the green cells. So I just like wondering what are the shapes. Do they do something? Because this shape looks like a heart to me. Or maybe like a sharp if I draw some strings here. Yeah, now it's a sharp. Or a sitar. I don't know. Anyway, that was a very cool puzzle. And I think that should be all for today. Once again, Apiyo, thanks for choosing a puzzle of mine as the way of introduce your viewers to the world of the variant Sudoku. That I liked it a lot. Like it's like the biggest thank you for the setter, I guess. I hope that you enjoyed my solves of your puzzles as well. Thank you. Bye.